Good morning. I decided to tailor a pre-existing sphere, and I chose one from the TRAPPIST system, and I chose TRAPPIST 1F to kind of critique and make my own. TRAPPIST 1F is approximately 41 light years away from Earth, and it is considered a super-Earth. It was first discovered in 2017 by the TRAPPIST telescope in Chile, and then the Spitzer Space Telescope followed up the discovery and kind of looked more into it. TRAPPIST 1F is in the habitable zone of its star, and there are 6 other TRAPPIST planets in this little system. When designing the interior for this planet, I took to NASA's website and did some searching, and I came across this image. And the one thing I really like about this image is the complete water crust. So for this TRAPPIST system, or for my planet, I have decided to go with an iron-rich core. It's going to be larger than Earth's. It's rich in iron and very dense. The mantle is going to be very thin with sulfur and other silicate rocks. And the crust is going to be water, like 99% water. And it is very deep in a lot of part of the planet. It's so deep that the pressure at the lowest points is so great it can create supersonic ice. This type of pressure isn't seen on Earth. Basically, figure it being about 1,000,000 times the surface pressure that we feel here on Earth. TRAPPIST also has a hole density very similar to Earth, whereas the mass is 0.68 times the Earth's mass. When designing the surface features for my planet, NASA explains the TRAPPIST systems to be mostly rocky, and TRAPPIST 1F is far enough away from the sun that it's thought to have quite a bit of frozen water on the surface, but I envisioned this planet with major surface water, along with some volcanic mountain ranges, and I've included stratovolcanoes and cinder cones scattered throughout the planet. Most of the volcanoes are active while the others are dormant. And there's also some underwater volcanoes and seamounts as well, and this is where a lot of the life on the planet is going to take place. The volcano chains are made up of granite, rhyolites, and dorite, and the ocean-type waters have very deep craters that were formed at the beginning from a major impact. These ocean craters are some of the deepest in the universe, and they were thought to be created by a major asteroid impact, similar to the Eltanian impact that Earth experienced. And this was such a large impact on TRAPPIST that it pushed water, the water pushed away made tsunami-sized waves for days up onto the volcanic ranges. Subduction is also a major occurrence occurring along the convergent boundaries. Ocean trenches are quite deep, and there are hotspot island changes constantly forming. And the chains are sporadic but plentiful throughout the planet, and these hotspot chains actually follow along the boundary lines, creating very long chains. Looking at the atmosphere and the hydrological cycle of the planet, I envision this with a very homogeneous atmosphere, very thick to help keep the planet warm, since it is a bit farther away from the sun that does have some cooler temperatures. I was hoping the thickness of the atmosphere would help keep the planet a bit more warm. The atmosphere is going to contain water, carbon dioxide, sulfur dioxide, and oxygen. And then with the ongoing volcanic activity and all of the water in the ocean presence, there is a constant steam rising into the atmosphere. As the steam rises, it gets trapped, and then it will rain. Just went with regular rain. And envision this planet is like one giant sauna. The air is very thick, and it just kind of live in a constant haze. There's not much breeze or wind. And the picture I've got on here is of a hot spring, but that's just kind of how I see the planet, with just a fog of haze of steam all around. Life on my planet is going to consist completely underwater. Since the surface is 99% water, everything is going to happen under the sea. I have several smaller organisms present. Some of these are going to be deep water sponges, deep water starfish, and along with deep water corals called octocorals. All of these feed off the bacteria and organisms that are within the currents on the ocean floor or on the ocean floor. And even though there is no light in these deep sea, life is aglow near the vents in the volcano bases. And speaking of a glow, since light does not penetrate the deep ocean, the animals have developed organs that can produce light and they're called bioluminescence. The marine life will either produce or emit light for the purpose of mating, luring or deterring prey, and for communicating. Some other properties surrounding my planet. TRAPPIST is going to orbit an M-type star. It's an ultra-cool dwarf star. It's called TRAPPIST, which is red in color, and it's a lot cooler and dimmer than our sun. It takes roughly 9 Earth days for TRAPPIST-1F to orbit its star, and F1 TRAPPIST is larger than Earth, and it is also closer to its sun than Mercury. TRAPPIST the star has the possibility to live a very long life. From what I've found during my research, this star could live up to trillions of years, and it's thought to be right now to be roughly about 500 million years. So there's still quite a bit of life left in that star. The view from this planet, or from the surface of this planet, is like none other, and due to the close proximity of the other planets in its solar system, many of the planets are clearly visible in the nighttime sky. So this picture here I have found from NASA as a artist rendition of what they thought life could be on TRAPPIST, and I just think that the ability to see all of the other TRAPPIST planets would just be a pretty awesome sight to see. And there's also a comparison of our sun to the TRAPPIST star as well. All right, and that concludes my rendition of TRAPPIST-1F. I will be around if anyone has any questions. Thank you.